Hello and welcome back to the next chapter of the course, which gets into section 12.1 for Math 120. So we're going to jump right in. We got 12.1, which is going to be on visual displays of data. So now just some basic definitions and terminology to get the ball rolling. So information collected that is not organized is called raw data or raw data, depending on how you want to pronounce it. Now, within that realm of raw data, there's two major types that you could have. So if the data is numerical, which is what we primarily like, because we like numbers, then it is called quantitative data. So the way to think of that is that it has a quantity, it has a size to it. So numerical is quantitative. But if the data is non-numerical, then it is called qualitative data. So it doesn't have a size to it, but it has a quality to it. So qualitative is non-numerical, quantitative is numerical. So just a couple of examples to illustrate is, so if we were looking at the number of kids in 9 families, we could have those different values. So, we have a family with 4, we have a family with 8, and so on. So this would all be quantitative data. But if I asked for 3 makes of automobiles and you said Chevrolet, Ford, and Dodge, that would be qualitative data. All right. So let's focus on the quantitative. One of the first things we can do with that is, of course, put it in numerical order. That just kind of makes it a little bit easier to see and to get information from that. So if we took those 9 families with the kids and put them in order, we can kind of see a little bit of a pattern. We have a couple of families with 1 child. We have a couple of families with 6 children. So it's just easier to kind of see the overall picture. So that's one of the first things we can do. When you have a lot of data, then one of the nice things you can do is put it into a table. And the fancy way to describe a table is a frequency distribution. So a useful table to construct is a frequency distribution which contains each of the distinct values of the data and how many times they occur, which is called the frequency. So how frequently do you see that particular number happen? An optional component in the table is each value's relative frequency, which is a fraction or percentage. And I'm going to underline percentage because that's typically what you want for a relative frequency of the value's frequency over the total number of values in the data set. All right, so that's where we're at. Now, if we want to look at this first table, I'm referencing example number 1A. So let's stop and take a look at that. Now, I actually made a mistake. It's not number 1 from the textbook, it's number 7 from the textbook. So let's take a look at number 7 and see what it tells us. So for the directions we got in each case, use the given data to do the following. So for part A, construct a frequency and relative frequency distribution in a table similar to table 2. So what do we got? A magazine identified the following 5 maintenance activities often performed by people as summer approaches. So number 1, prep the car for road trips. Number 2, clean up the house or apartment. Groom the garden, exercise the body, organize the wardrobe. So the following data are the responses of 30 people who were asked on June 1st how many of the 5 activities they had accomplished. So we have this raw data. It's not organized or anything, but again, it's how many of those 5 tasks did they get completed. So what we're going to have to do is translate those values into our table. So again, let me stop there for a second, and then we'll switch back to our table, our blank table. So we have those 30 values that we now need to, like I said, put it into this table. So the first thing we want to do is identify all of the distinct values that we actually see in that data set. So we do have zeros, we have ones. I'm looking at the textbook. We have 2s and 3s and 4s and 5s. And that's it. Those are the only possible distinct values that we have. So we're just going to write those in. So we have a 0, we have a 1, we have a 2, a 3, a 4, and a 5. Now the tally column is an optional column. You don't necessarily see those in a frequency distribution, but when you're creating your own, it's not a bad thing to do to have those in your table, because all you're going to use this for is just to kind of count and keep track of how many instances of each of those values you see. So if you go down the list, you can kind of just say, okay, I see a 1, I see another 1. You know, if you have your textbook open, you can kind of see this as well. So there was 2 1s, then there was a 3, another 1, a 0, another 3, another 0, another 0, a 2, a 1, and so on. And so you're just going to keep putting hash marks down for every instance you see until you go through all of the data values. So that's what I'm doing here, and I'm about halfway done, and I'm on the last row now. So it's a little bit tedious, obviously, but you know, if you take your time and go through it, you should be in good shape. So 1, 2, 3. All right, so that should be all of them. That should be all of them. Now, let's just translate those into actual numerical values, so that way we can count a little easier. So there was 10 here, there's 7, there's 6, 4, 2, and 1. Now, how can we confirm that we got them all? What if we made a mistake somewhere? Well, it's not a perfect process, but we can count our frequencies. Remember, there was a total of 30 values, so we should have 30 as a total of our frequencies. So we got 10, we got 20, 7 and 3 is 20, and then 6 and 4 is another 10, so there's 30. So we do end up with 30, and so we're good. So that would be just a plain frequency distribution. You have your values, you have your frequencies, and that's it. But when they ask for that relative frequency, you need that extra column. So let's read through it one more time. So the relative frequency is a fraction or percentage of the value's frequency over the total number of values in the data set. So in this case, we're going to want to take each of these frequencies and divide it by the total. So if we say 10 over 30 and we divide that, we're going to get 0.333 and so on. But now we want to change this to a percentage, so 33.3%. All right, let's do the next one. 7 out of 30. I think it's 23.3, but let's double check. So if we divide 7 divided by 30, we get 0.2333. So 23.3%. Okay, what about the next one? 6 out of 30. Well, 6 out of 30, I believe, is 0.2. So that's 20%. 4 out of 30. Again, let's make sure. 4 divided by 30 equals 0.133, so 13.3%. 2 out of 30, 0.06666666. So that's 6.7%. And then 1 out of 30, 0.0333. So 3.3%. So not anything too drastic. All of it's calculated work, but you get all of these percentages. Now again, how do you know you got those percentages right? Well, hopefully you've got all of them. If you have all the percentages, you have 100% of the percentages. So let's add them up and see what we get. 33.3 plus 23.3 plus 20 plus 13.3 plus 6.7 plus 3.3 equals 99.9. Well, it's not 100%, but it's pretty darn close. Keep in mind we did round a little bit in here, so it's not going to be perfect, but it's pretty close. All right, so that kind of gets the ball rolling with this. So we have our table view of data, which is pretty nice. Now we're going to see some other ways that we can display these datas. So we can use a histogram or a frequency polygon. So we'll see those in the next video. See you soon.